Let me welcome everyone to today's event. This is a webinar on blended data for evidence-based research and evaluation. Before we get started with the presentations, let me introduce myself. I'm Nathan Cruz of the U.S. Department of Agriculture, National Ag Statistics Service. I'm one of two co-chairs for the FCSM Computational Statistics and Production of Official Statistics Group, CSPOS as we like to call that. And today's event is based on some abstracts that we had submitted for a topic contributed session for the spring conference, FCSM conference on research and policy. So the FCSM interest group is comprised of 30+ employees from a variety of official statistical agencies. We're interested in exploring tools and techniques applicable for the production of official statistics. And my colleague, Matt Williams at National Science Foundation is a co-chair of that with us. If you are a federal employee and you're interested, reach out to him or to me to be included on the mailing list for that group. Among some of the other activities of CSPOS, we are instrumental in organizing the Government Advances in Statistical Programming, or GASP workshop. That's been held in autumn of 2018 and 2019. And we are planning a workshop for 2020, although it's anybody's guess as to what that event will look like at this time. I will invite you to browse some of the shared materials on the Washington Statistical Society webpage, as well as the 2019 talks that were recorded and shared on the WSS YouTube channel. Finally, just a little bit in the way of introduction and logistics. We have 5 speakers presenting 4 talks today. All of the speakers are members of our FCSM interest group or co-authors with members of the group. You'll hear from Lisa Frayhill of Institute of Museum and Library Services, Leland Crane, who's a senior economist at the Federal Reserve Board of Governors. My colleague Luca Sartore will present work on machine learning approaches for crop yield estimation, and then Baiwan Santiago Calderon and Brandon Kramer will share a presentation on valuing open source software through blended data approaches. If a question arises, we'll invite you to submit your question in the chat, and we can try and help moderate those questions as time permits. And with the introductions and logistics out of the way, let me stop sharing my slides here and invite Lisa to take the podium.
Well, thank you very much, and thank you both for organizing this session and keeping it moving forward. Let me go ahead and put this into presentation mode. Sorry about that. I think I can put it in presentation mode. So this is actually a project that I'm doing with Melissa Sadate at the U.S. Census Bureau, where she's a survey methodologist. And we got together at a Corporation for National and Community Service conference that was held last September, where she made a presentation about the American Housing Survey. I made a presentation about the Public Library Survey, and we decided that, hey, there might be some interesting ways that we can pull these things together. So this is very exploratory on our part. As always, the usual disclaimer, this is all us and nothing to do with either of our agencies or any other part of the US government. So I'm going to talk a little bit about our purpose, and our purpose is really twofold. We have a substantive purpose, which we didn't completely fully realize, as you'll see in a moment, and a methodological purpose about, sort of a proof of concept. How can we do this together? How can we work out a way to blend data from 2 different places? As I mentioned, the 2 sources are going to be the American Housing Survey and the Public Library Survey. And what I'm going to talk about is how our our blending was really what I'm calling sort of a sequential appending of data. And we'll talk very briefly about the findings and conclusions. So the substantive question is, there's been a lot of interest in looking at the ways in which libraries impact their communities and vice versa. And so collective efficacy is something that we think is important for libraries. We go all the way back to the research that Craig Calhoun did back in the early 1990s about public sphere institutions. And then fast forward, we get a lot of folks who do research on libraries looking at how libraries are public sphere institutions, how they facilitate civic engagement, how people can develop social capital, both by using library, but also how libraries facilitate the development of social capital. And that, you know, there's a sense of this collective efficacy that is brought about by, you know, neighbors participating in various civic organizations such as libraries. So there's been some prior studies in the wonderful world of libraries looking at the connections between, you know, their library and civic engagement, but they're all tend to be very like small level, you know, either qualitative approaches or approaches at a local level. And our question was, is there some way that we could use our two data sets to bridge that? So the big methodological questions are, what are the steps for blending these sources from very different places? What are the statistical issues that have to be addressed? And then mostly as well, what are some tips for cross-agency collaboration? So the American Housing Survey has been collected since 1973 by Census for HUD, and it's over 84,000 housing units. It's administered in odd years, and what happens is metropolitan areas sort of rotate through so that you can, over a course of time, you get a lot of different metropolitan areas. There's geospatial information included, and that's where, you know, well, we have geospatial information in the PLS, so that becomes our thoughts about how to blend. The collective efficacy module is just 1 year in 2013, 20 metros participated, and it builds on some earlier work that CNCS had funded in the current population survey with a series of items that were very much related to collective efficacy. So the Public Libraries Survey is an annual census of all U.S. public libraries, and it's actually at two levels. There's the administrative entity level, and there's about 9,200 of them, and then there's the outlet level, which is, it's not an electrical outlet, it means a point of service. It's either a branch or a bookmobile or a central library. We get a 95% response rate from this every year, so that's pretty exciting. It's because we have this federal state cooperative system where we work with state data coordinators in every state to get the data. At the national, state, and other subgroup levels, we do some aggregate level per capita estimates. For this particular paper, we did it at the administrative entity level. So the geospatial information is appended to both the AE, the administrative entity, and the outlet data files. So one of the things that we learned throughout this process was there was a real need for me to continuously simplify, because the notion was that Melissa had access to the restricted use data set, the AHS. I could only use the public use data set. And so all of my work had to be very self-contained and then sort of thrown over the wall to Melissa, who was going to do some additional work at her end, matching it up with the AHS in some miraculous way. So we decided to look at only a few of the indicators of library use. And the ones that you use the most are visits and circulation. Circulation meaning how many books get loaned out, books, videos, audio, materials. And then visits are how many times do people come to the library. So they're fairly straightforward. And then those are what I call the traditional indicators. The more new indicator is program attendance, because libraries have been running more and more programs and people have responded by showing up to more and more programs. So each administrative entity has a service area. That service area has a population. That population becomes the denominator when we look at reporting at the AE level. Visits and circulation are large enough, we can do them per person. program attendance we report as per 1,000 people, but I computed it for 10 people because, as you'll see, it scales kind of nicely when I do that, and we can put it all on one graph. So these are long-term trends in those three indicators: circulations, per capita visits, and program attendance for 10 people. And you can kind of see that, what we have is right in the middle of it is this decline, right? At 2013, it's right in the midst of this long-term decline after the increase. So what we ended up doing was looking at the point estimate there, the sort of the per person, for each thing there. But then we were also interested in the trajectory, so we took a slope on these lines. Now, those are the key analytical variables from the PLS. The key analytical variables from the AHS were a couple of variables associated with social capital. So the ones on the right, there's a 5-item Likert scale that gives us a measure of cohesion and trust in the neighborhood. And then there's one about social control in the neighborhood. And then the one on the left is more of a control for the sort of general aspects of the neighborhood. And then respondents also rated their neighborhood. So we have a couple of controls there. And then we have social capital as our main analytical variables. And for this paper, we did simple additive metric formation. Kind of interesting when I did it separately with a PUD using a factor analysis, a confirmatory factor analysis, I get the same results as if you do an additive with scales. So as I said before, this is really a series of multiple appendings. And my task was what I call pre-mixing. So we're going to blend, so you got to pre-mix some of the ingredients in the final blend. And so I had the data at the AE level and at outlet. Now those visits, circulation, and program attendance, those are all collected at the AE level rather than at the outlet level. So we have that kind of an issue you have to deal with, and I'll get to that in a moment. But we can link the AE and the outlet data using a unique key in both files. So we are able to bring them together. And because we were looking at metrics, per capita metrics at the AE level, we made this leap, this assumption that they would apply to any of the outlets within the AE span of control. That may or may not be a valid assumption, but we went with it. So that meant that we had this, now we had the PLS outlet file with some data elements appended from the administrative entity file. And then that gives you specific locations of library service points. That gets thrown over the wall and gets linked to the American Housing Survey collective efficacy module at the Census Bureau. So I'm going to just kind of wave my hand a little bit on that in just a moment. So the pre-mixing, like I said, meant that we actually end up with, when I say AE is not included in the study and AE is included, that means that we could, in our data, go through and say, okay, I'm going to put a flag in there for the units that are included in the AHS topical module and those that aren't, because they only had 20 metros in the American Housing Survey. So, so we could do a little bit of comparison and try to understand, are there going to be some biases due to, we're using specific metro areas, and you can see that we have a little bit of that going on, of course, because the metro areas mean we don't have a lot of towns in rural areas, and that we end up with, more AEs that have a lot of outlets. So when it went over to census, and Melissa is the one who did all of this, so I hope I get all the terminology right. She took the data that I gave her. We both work in SPSS, and so she took the SPSS file that I shifted from PLS. That was one file. She mixed the pre-mixed file. She transformed that into a CSV file. Then she took her 3 metro files for the AHS in CSV format, and she used a spatial join in ArcGIS, bring them all together, and then do some distance computations. Because in the process of our collaboration, we realized that it wasn't so much that the library was in the same place as a person, so much as how far away. That became the key variable for us, was how far away were people from a library. And was it the case that if people were closer to a library, that you would see, greater levels of collective efficacy reflected there. And so she did that in ArcGIS. Then she had to export into SAS and do her modeling in SAS. So we've got 4 different platforms and multiple ways in which we had to join the data. So the variables that we used, turns out, like I said, the proximity to the public library, we were working with that one, and that comes right out of the blending of the data between my data about the public library survey data and the AHS data about where people live. The library use indicators, the trends in those indicators, the social capital variables, cohesion and control, and then the neighborhood characteristics. And then another control that's tossed into the mix from a market housing standpoint is the housing kind of whether or not you own a home. So we ran a bunch of models, but we can't really show you any of those because we kind of ran into exigent circumstances, namely, the changes in our work duties and the changes in everybody's work duties due to this current circumstances we're in. But what we really came up with was, we found that there was some interesting findings with libraries and collective efficacy. And that was like very exciting for us, and really was spurring us to continue this work. And that indeed, distance to the library turned out to be a better predictor of social cohesion measures than were the social control measures. So our conclusions are, we thought this was going to be easy, right? And this is where we started. We thought, yeah, this is how this is going to go. We got this data, we've got that data, we'll just spatial match them and we'll let it rip. And that was not as easy as we thought. I think that's the big lesson here, was that it was a lot more complicated than either of us thought, both at my end from the PLS, but also at the AHS end. So the big questions, though, that came up really related to the units of analysis. I think that Melissa and I had multiple conversations about, what are we really trying to say something about? Are we trying to say something about people, right? Because that's the unit of the households with people in them are the unit of analysis in the American Housing Survey. Or is it that we're trying to say something about libraries, right? And I think that in some ways, we're trying to say something about both, but you really got to pull that apart and tease it up a bit. But that also has implications for what it is you're really doing on the blend, right? So if what we're trying to do is to understand what's going on with people, then we're basically appending some interesting data from the PLS to these individual, level records. But if we want to say something about libraries, it's a bit more complicated than that. And then the other thing is that was a big limitation, was that the availability of the data in the topical module for locations really posed a lot of limitations. First of all, it meant that I really couldn't access the data for the time being. And then we really had to be concerned about quality and disclosure. We had a lot of conclusions about the collaboration. And we really thought that there was a lot that we were getting out of this. Both of us as sort of, people, I think we were learning a lot from each other. But when we say keep doing these things, I mean, you don't want to let the barriers, get in your way of doing collaboration. And in my case, it was great because I had to really think hard about what it is I wanted to do with this process. And I felt that we had complementary skill sets. Like I said, I don't use ArcGIS, Melissa does, and she's a real whiz at it. So it was just a real value add from my standpoint, for sure. And we learned a lot of lessons. Like, there was just one of us from each agency, and it would have been really good to have a team from each agency. The problem is at my agency, there's me, and there's not a lot of other, we don't have other statisticians, we have other methods people that we could have pulled in, but everybody's oversubscribed. The big thing that came up was we weren't quite sure what to do about the sample weights. And that's where, we were thinking, well, gee whiz, if we're just appending this data from PLS onto these individual files, it might not be a problem. But if we were going the other way, it could be a real big issue. So we thought that was an unresolved issue that we'd want to include a sampling statistician in the team in the future. And then the data access and use rules were a real issue. We had to rely on Melissa, and we just didn't have the ability, given the timing of everything, both because it was Census 2020 going on, and it was hard to be able to move through access to restricted use data, but also because of the current circumstances. For our future work, obviously, we'd like to continue this. We have to figure out the weights, obviously. And then Melissa was talking a lot about geographically sensitive modeling, namely, trying to understand a little bit more about what's going on in those neighborhoods, and really not just a sort of, it's more about how people actually get to the library. So I want to thank you all very much, and I want to thank Melissa profusely. She has been fabulous, and it's just brilliant to work with.
All right, Lisa, thank you for your presentation. We may have a couple moments to field any questions that audience may have for Lisa, but I would like to ask you, you mentioned kind of the geographical aspect, and for us at USDA NAS, some of the phenomenon that we want to measure are, certainly spatial phenomenon, but at the same time, our list-based sampling may be based on a mailing list that doesn't necessarily coincide with, the agricultural field in question. So I guess the question is, if you were not able to perform kind of the geographical analysis, would that change your use of the data or the applicability of blending these data?
Well, I think in a sense, we originally started with the notion that we had to be able to join, the individual level households with something about the libraries. And so the geo data was important for that. Now, and I think that for, for what we were trying to do and the kind of topic that we were looking at, from a standpoint of a hypothesis, right, it made sense that people who are closer to libraries would have more of an effect of being close, of that library's presence in their community. And so, so that was something, so I think that for us, the geospatial aspects of this were pretty important, to work out. Does that answer your question?
Yeah, I think that helps shed some light on it. Peter Meyer, I think from Bureau of Labor Statistics, has a question to follow up. What were the measures of social control they were used to predict social cohesion?
Oh, so that was a set of items that came out of the AHS and were along the lines of, the neighborhood, and ask people, how likely are you to scold a neighbor would scold a disrespectful child, that a neighbor would step in if they saw fighting near their home, neighbors would act to save closing fire station, that they'd step in if they saw a child not in school, and a neighbor would step in if they saw a child spray painting. That is that, neighbors participate in implementing social control within the neighborhood.
I see. Thank you. Let's go ahead and invite Leland Crane to share his slides. And in this talk, I think we'll be looking at a blend of government statistics along with private payroll data. Thank you, Leland. Leland, you may need to unmute your microphone as well.
Okay, can folks hear me now?
Yes.
Yes, thank you.
Okay. Yeah, well, thanks a bunch to the organizers, and thanks to everyone for dialing in. I think this is really cool. I'm going to be talking about blending privately provided payroll data and government statistics. This is joint work with a bunch of my colleagues at the Federal Reserve Board of Governors. And of course, all the usual disclaimers apply, that the opinions here are not necessarily those of the Federal Reserve System, and all results have been reviewed to ensure no confidential data are disclosed. Second, let me give you just a quick outline of what I'll be talking about today. So most of the talk is going to be about our data, our processing, how we weight the data, and then a state space model that we use. And then at the end, just very briefly, I'm going to talk about some weekly employment growth estimates for the past couple months, since this has been in the news a lot and has suddenly become much more relevant. So our big question in this project is, how can we combine official data with alternative data in order to improve the accuracy of economic measurement? So we're focusing on payroll employment, just measuring the number of jobs in the US each week or each month. And our approach is to build a payroll employment index using an alternative data set from a private payroll provider, ADP, and I'll talk about them in a second. We use official data in a lot of different ways. So we use it to reweight the alternative microdata. We use it to benchmark the historical series. We use it as a forecasting target to validate what we're doing, to show that we actually can extract some useful signal. And then at the end, we use a state space model, which is just a way to combine the information that's in the alternative series with the official data, treating both as noisy indicators of true underlying employment growth. And that should be clear, government statistics are critical for what we're doing here. This is not something where we're trying to build a competitor to the CES survey or anything like that. So let me describe our data set. Our data are based on records from the payroll provider, ADP. They run from 1999 up through the present. And ADP processes paychecks for about 20% of US workers in the private sector. So essentially, outside of government, 1 out of 5 workers has their paycheck going through ADP's system. And every pay period, client firms send ADP the information on how much to pay each worker, tax withholding, a bunch of other information. And we're able to see extracts of that data, so anonymized information, but microdata. And we do a lot of work. This has been kind of years of our lives at this point. So we take the microdata and build estimates of monthly private total employment. And we try to model what we do off of what BLS does. We try to, in a lot of ways, we try to copy their methods and their techniques. So a couple words about the strengths and the weaknesses of our data. One nice thing is that we observe all the pay periods. So rather than just a snapshot from the middle of the month or from like 1 month out of a quarter or something, we see every pay period as they come in. So the data is, in a sense, continuous. The data are not a probability sample. They're more like a convenience sample, in that to be in the data, the company has to have a relationship with ADP that is, of course, going to be selected both on observables and unobservables. But we do find that the raw data actually are approximately representative along a number of dimensions. So I can show you just the industry breakdown. This shows the employment shares in the ADP data across different industries, as well as in a couple of the government data sources, the CES and the QCW. And you can see they're broadly similar. There's definitely differences. ADP overrepresents the manufacturing sector. But in general, things look approximately representative, which is very reassuring, and we'll be reweighting things to try to make them even more representative. And this last bullet point is just that in terms of real-time measurement, the nice thing is that the data are kind of continuous and we get them every week. So at the end of the week, we get data for that week. And there's no lag in reporting, which is especially nice these days. I'll just say a couple words. I'm going to be talking about CES and QCW a lot. For those of you who are not labor economists or labor statisticians, CES is a survey run by the BLS. You probably hear about it every month, probably, if you're reading the news. It'll be coming out on Friday, and it's going to get a huge amount of attention. This is a monthly employer survey. It comes out 1 week after the end of the reference month. It comes out quite fast, and it actually samples about 20% of US employment. So it's a truly massive survey in a lot of ways. That said, there is significant measurement error in the real-time estimates. And BLS is very upfront about this, that despite being a huge survey, there is still significant sampling error, and there's other unavoidable forms of error related to births and deaths and other things. So all of that is just to say that there is some room to add data and to potentially add signal to CES, even though it does a remarkably good job. The second data set that we use is a QCW, which is a census of employment. It's based on unemployment insurance records, but it's only available with a long delay. So it comes out 6 to 9 months after the fact. So for those of us who are interested in what's happening this month or this week, it comes out with too much of a delay. So let me just show you our series alongside the CES series. So the red line here is the series that we built based on the payroll processor data, and the blue line is BLS's survey. And these are in the change in the number of jobs and thousands of jobs per month. And the nice thing here is that they line up quite well, at least over the business cycle. You can see the Great Recession there. They both behave very similarly, though there's a lot of high frequency wiggles where they disagree. We think there's noise and measurement issues in both series. I'll just note that these data are plotted through February, so they don't show the recent employment declines. Now, how exactly are we kind of blending in official data into our production process? There's a couple ways. Well, first, I mentioned weights. So we do try to make ADP more representative, at least on observables, by reweighting by industry and size class based on QCW data. We also benchmark our data to the QCW when it arrives, so that just makes sure that the historical trends in our data are accurate or matching up with the census data, essentially. And it also lets us know if there are persistent errors in our series. So one thing we worry about is if ADP starts drifting off and consistently reporting higher or lower growth rates, that would indicate that something was amiss, and this process forces us to think about that. And this is kind of benchmarking procedure is, again, modeled on what the CES program does. And then the last thing that we do using official data, or one of the last things, is to test whether our series can predict what happens in the CES on a month-by-month basis. So we get our data a little bit earlier than CES comes out, so we can test whether we, on the eve of the release of the CES data, can we predict something about what's going to come out. And I won't go through the whole regression table, but we do find that the ADP data are statistically significant predictors, even after we control for a lot of things, including the market's expectations of the CES release. That though we get statistical significance, the improvements in the root mean square error of the real-time forecasts are not huge. And that leads us to our next question, which is really, what is the best use of the data, of the ADP data? And do we really want to forecast CES? So as I mentioned, CES does have a number of measurement errors. There's sampling error, the birth-death adjustment, et cetera. So our approach is instead to try to combine the signal that we get with CES and in a state space framework. So we think that both CES and ADP are noisy signals of the truth, and we're going to try to get the signal that's in both of these series. So our state space model is a Kalman filter. It's just based on a couple simple assumptions. The idea is that there's an unobserved state variable, which you can think of as being true employment growth, which follows a persistent process, an AR1. And then CES and ADP are both noisy signals of the truth. So they're just the true process plus some noise that is, you can make different assumptions about it, but the noise is not too persistent and the noise terms are not too correlated. So we feed the data into the model and we extract estimates of all the parameters, including the observation noise and estimates of true employment growth. And this is what we get. So this is similar to the chart that you saw before, except that we have the black line, which is the smooth state estimate, which is combining the signal from both the CES and ADP. You can see that it often does tend to follow both series and is usually somewhere in between them. We have the confidence intervals there as well. So this, let me see, a few more words to say about that. The Kalman filter implicitly puts weights on the two observable series when trying to extract the unobserved variable. And it turns out that it puts roughly equal weights on CES and ADP, which is consistent with the idea that ADP samples about 20% of the population. CES also samples about 20% of the population. So in some sense, they're equally sized samples of the full population. So you might expect them to get equal weights, roughly speaking. The results are robust to changes in a bunch of assumptions, the persistence of the state, the correlation of the observation noise. I'll skip that last bullet point. So once we have these state space estimates, we can again try to see whether they're useful. We do find that they're useful. So we see that the state space estimates outperform either series individually, or each series taken separately when we try to forecast, for example, CES or something else. So the state space model does seem to be giving us forecasting value in real time. So now I just want to say a few words about what we've been working on recently. As you know, well, this should say that the labor market has been changing very fast over the past couple months. The data from ADP that we use are fundamentally weekly. We've been mostly thinking about monthly frequency stuff, but we get data every week. And so this is one case where that's really valuable. So I'll show you some of our weekly employment indexes. These are built, basically the same way as what I discussed in the first part of the talk. They're all reweighted using the official government data, seasonally adjusted, all the other stuff. And I'll show you two series. So one is what's called paid employment, and this is the number of workers who actually got a paycheck. The second series is active employment. And this is a little vaguer, but it's the number of workers that the firm keeps in their payroll system. So workers who may not have received a check this pay period, but the firm expects to work soon or in the near future. In typical times, that would include people who are on vacation or just didn't get any hours. Under the current conditions, we think there's a lot of people who have been put on temporary layoff or furloughed. But the firm hasn't purged them from their payroll systems. They're still thinking that those workers will come back to work. So let me show you the results. This plot is showing the weekly data, and this is all indexed relative to the levels on February 15th. So you can see February 15th, the series are equal to 1. Focusing on paid employment, the dotted line, the dashed line, you can see that that's fallen almost 20% by April 18th. So that is a huge decline. You know, that's 1 out of 5 workers not working, essentially. You can see that active employment fell significantly less, and that's consistent with the idea that many of these workers who did not receive a paycheck recently are expected by the firm to still maintain a relationship. They're still at least tacitly attached to the firm. The firm hasn't necessarily gone out of business or permanently fired these workers. The other interesting thing about this is that you can see in the weekly data that the declines in employment seem to start before the lockdown orders, which came around March 16th and the days immediately after. You can see that there were smallish but still visible employment declines before that happened, suggesting that businesses and consumers were pulling back in advance of the lockdown orders. And you can also see that the employment declines appear to have leveled off in recent weeks. It seems like a lot of the adjustment did happen before, say, April 4th. So that's all I have. In terms of conclusions, we really do think that alternative data can help improve the accuracy of economic statistics, if used judiciously. We use official data for weighting, for benchmarking, for validation, for signal, and finally for signal combination. We think that statistical agencies could potentially use data from payroll processors to increase their implied sample size. And there'll be some more stuff coming out on the high frequency stuff that I talked about at the end with an expanded list of authors. It should be posted next week on the Becker-Friedman Institute webpage. And then lastly, I just listed the papers that I referenced here in case anyone is interested. And that's all I have. Thank you.
Thank you, Leland. I'll open up the floor for a couple questions, but in the meantime, in the time series, you plotted the red, black, and blue lines. As we got to the end of the time series, there seemed to be a pretty significant departure of the red line from the other two. Can you give an explanation for that? Is it all related to current events or something about the payroll data?
Yeah, so that is, that's absolutely something we've been looking at. There's always, I'd say that some of those estimates are retrospective. So for example, the state space model sees that the ADP series and the BLS series eventually converged near the level of the BLS series. And so it implicitly goes back and thinks that that true employment was following the BLS series all along. There's absolutely some dynamic selection issues that can arise in the ADP data. And there's also potentially issues in the BLS series. We know that CES was running below the QCEW, so the survey was running below the census of employment over the course of the last year or two. It's not clear exactly why. We were working on this very hard before February, and then we had to drop all of that. So I don't have a really great explanation for that divergence. I'd say that's something that as of early February, we were really, really interested in, and it got kind of pushed down the priorities list.
Understood. We do have one more question. This from one of my colleagues at USDA. Jennifer Rohr is asking about the coverage of the ADP data for the agricultural sector or ag workers. Are there particular groups of workers well represented or not well represented in that data?
Yeah, that's a great question. I think that for ag workers, I'll say we have not explored that in depth because our target has usually been private non-farm employment.
I see.
That said, I know there is at least a little bit in there, but I couldn't say how good it is, in proportion to the rest of their coverage. More broadly, we would be very, very interested to get better coverage of like contractors, so like gig economy types of workers. That's something a lot of people have been thinking about, and we're hopeful that that some of the payroll providers who work with those workers would be able to have data.
Well, wonderful. Thank you for that. Thank you for your presentation, Leland. We'll continue on with the next presentation. Baiwan Santiago Calderon and Brandon Kramer will present an approach for placing an economic value on open source software, which by definition seems not to have a dedicated marketplace. So tell us how to do that.
Hi, can everyone hear me? Yes, perfect. Thanks for being here and to the organizers. My name is Baiwan Santiago Calderon. I'm a postdoctoral research associate at the Biocomplexity Institute Initiative at the University of Virginia. I'm an economist by training. We also have Brandon Kramer. He's a postdoc at our division and he's a sociologist by training. And today we're delighted to share some of our work on open source software. This project is a collaboration between our group, Social and Decision Analytics Division at UVA and NCSS. Sam Kortmax is the project lead at the UVA site, and Carl Robbins is the lead at NCSS, and Sally Keller is our division director at UVA. So this cooperative agreement between UVA and NCSS looks to explore and find an application of how data science research can enhance, improve, redesign current surveys on R&D, innovation, skilled science, engineering, education, workforce data. It's a multi-year project that's aimed to improve indicators of research output, which is one of the core missions of NCSS. And right now, we're presenting some of the work that we have done in developing reliable data around the economic activity of developing and maintaining open source software. Next slide. So a little overview for the presentation. I'll first talk about how we define the universe of open source software. I'll go into our cost estimates and some proposed impact measurements or measures. And later on, Brandon will talk about some of our work analyzing contributors networks, as well as international collaboration networks. Next slide. So current NCSS and other economic indicators do not measure the scope and impact of open source software that's developed outside the business sector. That means that we have a gap in data to answer basic questions such as how much open source software is out there. That's a stock measure. How much is being developed each year? It's a flow measure. And who creates it? Business, is it households, governments, academia? These are important questions in order to incorporate into the national accounts for a huge sector of this economic activity. And lastly, we want to identify data sources and variables that can be used to measure the cost and the impact of it. Next slide. So first off, what is open source software? That is software that is published under an OSI approved license. And that license basically establishes the permissions, the use, and basically limitations on what you can do with the software, whether inspect it, contribute to it, modify it, etc. Some common licenses are MIT, Apache, the General Public License, and others. Next slide. First off, I wanted to make a distinction between a project and a repository. Repository is the collection of lines of the code, the source code, while a project is a lot more. Basically, when a project it's akin to in the business sector when you develop a product, but then you have to support documentation, marketing, and all those services around the core project that actually makes it succeed or useful for the users. So our estimates only right now look at the source code or the core product, but that basically means that we're doing an underestimate of the actual impact and the cost. Next slide. So when we were starting off with the project, we wanted to get some guidelines of what we wanted to approach. And some guiding questions were, what do we consider open source software? Is it a Stack Overflow answer open source software? Is it a student homework or a template, or is it a package that's meant to be distributed? We wanted to know whether it should be production ready or maintained, basically has a sense of how usable it is, and whether it's discoverable or installable, basically on if it's outdated or is it current for the common ecosystem. And we came up with two solutions. And the first approach is looking at programming languages and what packages are available to those. And the second one is looking at where the code is being hosted. And we looked at GitHub, which is the world's largest remote hosting platform. Next slide. So the first approach, I like to describe it as being really intuitive. If one wants to know what are all the apps that are available for an iPhone, one goes to the App Store. And registry, basically what has is the data needed to install what is available, contains metadata and where to get it from. So we do that for R and Python through the Comprehensive R Archive Network, CRAN, and the Python package index, PyPI. And we'll look at each of the modules available there. We'll look at the metadata to know whether it's usable for that status of the ecosystem or version of the language. We look at the license, and then we look at the actual source code. If it is on GitHub, we look at the license, and then we get the commit data. Commit data is who did what when. So we have information on every change to the source code. And later on, we take the information of who's contributing, and we analyze and profile the contributors. We perform the data harvest exercise for CRAN and PyPI. So our data dates to July 2017. Next slide. So when we look at the package census, how much OSS is available, we see that for CRAN and PyPI, Python has a larger amount, but that might be double counting for Python 2 and Python 3 versions of the language. When we go to OSI approved and production ready, basically checks in continuous integration, whether all the tests pass, etc. We see that they're about the same. The packages that are on GitHub, we see that Python packages are more prevalent there. And lastly, we have the packages that we were able to obtain information for. Next slide. The second approach is looking at where the development actually occurs. So we look at every public repository that had an OSI approved machine detectable license on GitHub. It was not a fork or a mirror. And then we collect the development activity for that repository. Every commit, when it happened, the lines are added, etc. We also collect information about the contributors, such as names, emails, organization, location, company that have self-provided. And we supplement that data exercise with the GHTorrent project, which already had a lot of data, but they were missing some key variables. So we collected those variables through the GraphQL API for GitHub directly. Next slide. So for the GitHub census, we see that every year we have an increase of how the annual number of new repositories being created on GitHub. These are public OSI approved licenses. And for 2019, we see that we have a lower than expected number. We believe that's due to a lag effect on maybe repositories are being developed, closed, and then open up for the public, or they're being developed and then they're licensed. That's what we are suspecting. For the distribution of the licenses, we see that early on, there were a lot of copyleft licenses like JPL, but right now the current ecosystem and the trends lead us to believe that permissive licenses are the most prevalent. That means MIT, Apache, which allow for more flexibility. Our GitHub dataset includes over 3.3 million distinct contributors and over 7.8 million repositories. Next slide. Looking at the project sizes, we see that 3 out of 4 repositories are mostly a sole contributor repository, and most of them have fewer than 5 contributors. So, for the cost estimation of open source software, cost estimation of software development and engineering, it's a hard problem. We look at a solution or the standard from software engineering, which is the constructive cost model approach, with its latest version being the Kokomo 2 model. And we look at thousands of source lines of code and to represent basically, or a proxy of effort. So we collect that information, we feed it into the model, which is a nonlinear model, taking the complexity and the lines of code. We then go from effort and convert it to nominal development time. And lastly, we apply a monthly wage, that would be a person month aspect to it, in order to get a development cost for the wage. And then we apply a factor for non-wage costs, adopting methods from OECD and BEA. Next slide. So for the package approach, we see that PyPI and CRAN had around 14,000 packages that we analyzed, totaling to $2.4 billion. That's 2017 dollars. And we see that for GitHub, using lines added as an input, we get an estimate of 928 billion 2017 dollars. And the data was collected up to 2019. Those are some of the top 5 repositories. We also want to get some sense of the usefulness or impact of the packages or the software. Just because they're available doesn't mean that the people are using them. So one proxy of them, with all its caveats, is downloads. And we see that for CRAN, RCPP is or was the #1 package in terms of downloads in 2018. But rather than just looking at downloads, we can also look at reverse dependency or reuse. It's akin in the bibliometrics to a citation, where you're building upon the work of others or that package in this or that tool, or you're expanding the functionality of that package. And to the right, we have a dependency network, a reverse dependency network for a snapshot of CRAN. And we can look at the nodes, which are the circles, those are a package, and they have arrows directed. That's that another package or another node depends on. So a lot of packages depend on ggplot2, and same for RCPP, for example. We can also see communities forming up on visualization communities in purple. We see the teal community is based on HTTP, Perl, XML, JSON, which are web-based technologies. We see the RCCP community, which are interfaces with the C language, and others. And for more network stuff, I will leave it to Brandon to talk a little bit about contributors and international collaboration networks.
Great, thanks, Bayoan. So building on that example of network analysis, we also wanted to start understanding some of the tendencies of international collaborations within the context of open source software. The previous literature in from the bibliometrics research has shown us that international collaboration has more than doubled in academic papers since 1990, and that governmental funding, especially from countries outside of the United States, has really bolstered these patterns of international collaboration, not necessarily leading to more overall publications, but certainly leading to higher impact publications. So building on those insights, we started asking questions just to get a general baseline of what international collaborations in context of OSS might look like. And in this presentation, we're going to try to answer some of these questions. Which countries are most likely to contribute to OSS? Which countries are most likely to collaborate across international boundaries? What is the overall structure of international collaborations? How do those change over time? And which are the most influential countries in the OSS ecosystem? To answer these questions, we're going to lean heavily on social network analysis. For those of you who aren't familiar, This is a scientific framework that helps researchers conduct structural analyses of various relational entities. And then we can visualize those through graphs using nodes and edges. So in this presentation, we're going to focus on two types of networks: overall GitHub contributor networks, as well as country-to-country collaboration networks. So again, our data in this portion of the presentation, we're going to be using the GitHub data, which the original data set is comprised again of 3.3 million distinct contributors and 7.8 million distinct repositories. We're then going to supplement this with GH-torrent's location data, which is essentially city, states, and countries, and then we recode those all into valid country codes. So that ultimately brings our data set in this portion of the presentation down to about 700,000 contributors and 3.6 million repositories spanning from 2008 to 2019, and those all have valid country codes. So as you can see in this bar plot, the country with the highest prevalence of users on GitHub is far and away the United States. They have roughly 4 times the prevalence of their closest competitor in China, UK, Germany, and India. So to take that data and format it as a network, we essentially started with 2 columns where you have contributors and the repositories that they are committing to. That's best visualized on the left-hand side, where you're looking at blue nodes, which correspond to contributors, and they're committing code to this orange repository, which is the node in orange. In order to kind of flatten this network and just look at contributors, we did what network scholars call projecting the network, and essentially removed that repository, and you end up with the visualization on your right, which the blue nodes correspond to contributors and the ties between them corresponding to the number of shared repositories they commit code to. So again, in this presentation, we're focusing on these contributor networks. Again, the nodes are contributors and edges correspond to common repositories, like I just explained, as well as a second type of network where we look at country-to-country collaborations. And in these networks, nodes correspond to countries, and edges correspond to the number of international collaborations those countries share together. We analyzed these networks with 2 packages in R, iGraph and gggraph, and also created some visualizations in the open source software Gephi. Okay, so jumping into the contributor network dynamics, overall what we see here is from 2008 to 2019, the number of nodes, edges, and overall commits grow exponentially over time. And this should not be surprising given what we know about GitHub and its how many people are using this platform currently to develop software. The other thing of note is something that Baiyuan just mentioned, is that the overall totals in the nodes, especially in the nodes and commits, are a little bit lower in 2019. Again, though we scraped this data about 2 months ago, well into 2020, we expect these totals to be a little bit higher if we scrape that data a little bit later on in the year. Essentially what we're seeing is a lag effect based on users creating repositories in earlier years, but not adding licenses to those repositories until later on in the year. So if we, again, scrape that data a little bit later on in this year, we'd likely see those totals jump up a little bit, corresponding to the exponential growth we've seen in previous years. Next, we're going to jump to the country-to-country networks. So there's a lot going on in this particular graph, so let's break it down. On the left-hand side, you essentially see a country-to-country network of 214 different countries that arise in the last year of our overall data set. So these nodes also have different sizes and different colors, and we're going to jump into that in the following slides. First, what we have here are edges that correspond to the number of collaborations between countries. And rather than the thickness of those ties corresponding to the number of collaborations, we've kind of weighted those based on color here, with the darker colors corresponding to more collaborations and the lighter colors corresponding to fewer. So as you can see here, the US is at the top in orange, and that country has many more collaborations, or has the most number of collaborations as indicated by the black ties or the black edges. We also see that countries like Japan and China have heavier connections, as well as a number of the countries in the bottom left-hand corner of the graph, although those ties are a little bit obscured in the current visual. Other main things to point out here is that when we look at the network descriptives, the overall density is about 0.48. This is relatively high, especially in comparison with the other contributor networks that we saw in the previous slide. Relatively speaking, the 0.48 is in comparison with about 0.0001. So you can see that overall, the number of countries that are connected is much higher in this particular graph. In other words, the average node in this country-to-country graph is likely to connect to many or most other nodes in the graph. This is also kind of driven home by the average degree centrality. The degree centrality in this network essentially tells us that any given node is very likely to be connected to other nodes in the network. In other words, most countries collaborate with most other countries in this particular network. Okay, so different kinds of centrality measures tell us different things about these networks. And while degree centrality is important to know, we can kind of understand this if we just started looking at the number of common connections that one country might have with another in kind of more traditional data analysis approaches. But what we ultimately want to do is look deeper into what network analysis gives us, and these graphs are a great example of how different centrality measures tell us different things. So in these two graphs on the left-hand side, first you have the top 15 countries in our network, and where the node size corresponds to the degree centrality. As you can see, there isn't much variance, and overall, the size of the nodes are about the same. Now this stands in sharp contrast to the graph on the right, where the node corresponds to the betweenus centrality of a given country. Here, the betweenus centrality corresponds to the overall brokering or bridging capacity that a country has. In other words, a country that has a higher overall betweenus centrality has a higher capacity to bridge information across disparate groups or disparate countries. So in this example, you see that the countries like the US, the UK, Canada, Germany, and China all have a relatively higher capacity to broker knowledge in the OSS community than do other countries that have smaller relative betweenus centralities. So this is important just in terms of being able to broker or having certain kinds of power to share information within the OSS community. Another way of looking at this is by just simply graphing the betweenus centrality on the y-axis against the degree centrality on the x-axis. And as you can see here again, the US, Canada, Argentina, Nigeria, Kenya, and Togo all have a relatively higher betweenus centrality than the degree centrality. Again, just showing that they have a higher capacity to broker knowledge within the OSS community. So I also mentioned that in the original network, we have the nodes have different colors. These correspond to what's called community detection in the network analysis community. So what we've done is we ran a modularity algorithm, or Newman's modularity algorithm, to detect different communities within the country-to-country collaboration network. What we ultimately found is 4 different communities. First, we have the US in orange, or the US and about 15 other countries. A second group that is centered around Japan and China, as well as about 10 other countries in red. A third community, which is mostly based around Canada, Australia, and a number of European countries in light blue, as well as a fourth group that's based around countries like Brazil, India, as well as many countries in Central and South America, Africa, and Southeast Asia. Now, what binds these countries together, we're still exploring in further detail. We know that there's some mixture of geographical, economic, and socio-political factors that might bind these countries together. But we would be very open to hearing more comments and suggestions about what is binding these communities together in more detail. So ultimately what we're trying to do is not only develop what these factors might be, but also to test different community detection algorithms to see how robust these particular groupings are. So to summarize, we essentially looked at these 2 different networks, and we found that when we look at the contributor level networks, US-based users are most likely to contribute to GitHub, and over the past decade, GitHub's network size has grown exponentially, but exhibits a similar structure to what we'd expect in scientific collaboration networks. When we turn to the country-to-country networks, we see that some different centrality measures tell us different things, and they ultimately reveal that countries like the US have a higher influence in the OSS community, especially when we look at their between the centrality. Lastly, the country-to-country networks tend to cluster into these 4 large communities. And while we don't totally understand, we know that some combination of socio-political factors are shaping what bind these things together, or bind these communities together, and that may have a huge impact on OSS development leading into the future. Lastly, I just want to comment on some policy implications of what our analyses have shown. Generally, we know that the national accounts capture software currently through these 3 pre-existing categories, but don't necessarily capture OSS in as well as we would like. So what we're ultimately trying to do here is enriching the national account, or enriching data for the national accounts. And one way of doing this is by adding the administrative data that we've scraped from GitHub here, and using that to complement existing survey research on open source software. One of the best ways to do that is looking into network analysis like we've done here. So we're just hoping to add in these alternative frameworks and really try to understand the relational structure of the OSS community, as well as the impact that they might have on the global economy. So I just want to thank you for your time, and we appreciate any comments or questions. Thank you.
All right, thank you to all of our speakers today, and thank you to Baiwan and Brandon for this presentation. I'll open up the floor for any remaining questions for these speakers or any of our speakers. And let's see, our first one from Sarah Grady. She asks, why is the usage of GitHub so much higher within the United States?
Yeah, I can answer that. It basically mirrors what you would expect on development in general for software. Sometimes in a lot of survey data, China gets played down as a little bit, maybe sometime measurement error or through like the instruments that they use, but software, a lot of it is being developed in the US. So it kind of mirrors that pattern. Some developing nations do show up more often, for example, like Germany and the UK, but it basically mirrors what you would expect from other data.
I think I'd like to ask a question about the 4 communities worldwide. You know, when I think about working on an open source project, you know, there's some aim in mind. Is there a sense in which, you know, some of these communities are, you know, working on the same types of problems that things in more developing nations may be focused on their needs and concerns versus those of other developed nations?
That's a great question. I think there's a lot of room for us to explore a bit more. What we're realizing is right now we're still trying to understand kind of the global structure of this collaboration community. What these communities indicate are kind of smaller subsections that are likely bound together. I didn't really mention linguistic factors, but we think there's something there at play, just to go back to that visual. So I think the next step is for us to kind of further explore these kind of subgroups. And what we're hoping to do is kind of recategorize the data based on city level, country level, state level, and really try to understand what specific projects are being developed within these different communities. Not only the communities we detected here, but also those different geographical levels that I just mentioned. So that's still an open question. We don't have a good handle on what projects or even what languages are being used in these specific communities, but that's kind of a step for future research.
Excellent, thank you. Are there any questions for our speakers before we adjourn for the day? Well, I think we're nearing the end of our allotted time. I'll invite you all to reach out directly to the authors if you have specific questions about their contributions. But I want to thank everyone for their interest and attendance. I think it's important that we thank our colleagues at the National Science Foundation for opening up the infrastructure to share this, as well as some of the individuals and organizations that helped us get word of mouth out about this event. Thank you very much. We'll conclude for today and wish you all a very safe and happy weekend.